So in this example, I'm asking you to explain why this function is always continuous. What that means is it has no discontinuities. If we look, the types of discontinuities we can examine from the graph are infinite, vertical asymptotes, and removable, holes in the graph. In order to have an infinite discontinuity, we need to have a 0 on the bottom, not on the top. So let's look at the bottom of this function. We have x squared plus 1. And as I just said, in order to have an infinite or a removable discontinuity, we have to have a 0 on the bottom, so that has to equal 0. To try to solve this, we can take the 1 to the opposite side, subtract it over. To get x by itself, we take the square root of both sides, cancels the exponent, and we get x equals the square root of negative 1. Well, as we know, we cannot have the square root of any negative number, let alone negative 1. So by looking at this, by examining this, we will never have a 0 on the bottom. So we can never have an infinite discontinuity, we can never have a removable discontinuity. The only other type of discontinuity that we could have is a jump. Jump discontinuities occur in one of two situations: an absolute value function, which we do not have, or a piecewise function. That's a function that's been defined in terms of two equations. We don't have that, we have just one equation, so we have absolutely no discontinuities, so then we can say that this function is always continuous.